Here's a question for you. What's hot, messy, and impossible to control? If you said Amy Winehouse, you get half a point. I was kind of thinking more along the lines of nuclear fusion. Because this week, in what could, and I emphasize could, be one of the biggest breakthroughs ever, researchers from the US Navy's Space and Naval Warfare Center unveiled what they claim could be evidence of cold fusion, something that's never been done before. What's the huge deal with this? Well, fusion is what happens inside stars and thermonuclear bombs, right? When the nuclei of atoms join together. But it's really, really messy because nuclei have the same charge. So they repel each other, just like magnets. If I want to combine these two solid magnets into a single entity, I'm going to have to add massive amounts of energy and heat, and unfortunately the killjoys at occupational safety won't let me build a coal-fired iron smelter here in the studio. But if we could somehow unite these repelling solids in a cool, controlled, low-energy environment, then fusion could produce unlimited amounts of clean energy, which is why it's been one of the holy grails of science. 20 years ago, a couple of researchers thought they'd cracked it. It was huge news back then.
What may be a tremendous scientific advance tonight in attempts to create and harness the almost limitless, clean power of nuclear fusion.
But that turned out to be just a false alarm. Which is it now? If it's real, it's one of the biggest breakthroughs ever. If it's not, well, at least we've still got Amy Winehouse, I guess. To sort this all out, joining me from Washington is Brink contributor, nuclear physicist and senior science advisor at the US Department of Energy, Dwight Williams. Dwight, what exactly have these researchers done?
Well, it's pretty simple when you think about it. They took some electrodes, some nickel or gold electrodes, put it in a solution of palladium chloride mixed with heavy water. That's actually D2O instead of H2O. They ran a current through it, and the output that they got on their CR39 detection system indicated the evidence of neutron generation. And of course, neutrons are clear evidence of fusion.
What was the objective when they were starting out? Were they trying to create cold fusion?
Yeah, I think their intent was to create cold fusion, and so far the evidence does not discount that cold fusion was produced, but as of this point, all the jurors are still out as to whether this was indeed cold fusion. Simply the evidence of neutrons does not mean that fusion took place. There are other reasons why you might get the neutrons.
What else could they imply? What else might be going on here?
Well, it could be any number of things. Of course, as we mentioned, option A could be fusion. Option B, it could be some type of radioactive or chemical radioactive process that we don't even know about. This could be big in a discovery of that sense.
Now, as I understand it, one of the big problems with cold fusion has always been that obviously nuclei don't attract. They oppose each other because they have the same charge. How are they getting around that physical problem? And is this kind of a chemical workaround to that physical problem?
If this is cold fusion, then yes, it is a chemical workaround to the problem. And as of right now, no one really seems to have a firm grasp. There are lots of varying theories as to if this is indeed cold fusion, how they might be getting around this. But so far, there are lots of possibilities, but no definitive answers.
Now, you're a physicist. For you, surely one of the absolutes of physics is that if there are like charges, then they repel each other. Does that make you skeptical about the idea that this is possible?
Well, it doesn't make me skeptical. I would say there's enough evidence to support the findings. For example, it has been repeatable. According to the researchers, there are clear evidence of neutrons. So basically, I would say that I'm not skeptical. I'm not convinced just yet. If you go back 20 years to what ended up being a false alarm, you know, again, there are many yellow flags that came up immediately. Again, like I said, things weren't repeatable. Heat generation wasn't there. The neutrons weren't there. Normally, by this time, I would have been convinced that it's not fusion. But right now, I'm still able to be convinced.
Wow. So if it is cold fusion and it can produce energy into the future, is the power that it could generate limitless and clean?
Well, yeah, theoretically there's an upper limit. The upper limit would be the amount of water that there is in the ocean. Certainly.
That sounds like a pretty generous upper limit to me.
Yes, I mean,
Once we've exhausted all of the oceans in the world, we're not going to be able to use it anymore. What's that going to be? A million years, a billion years?
Exactly. Yes, and again, I mean, again, we're talking, just plain old regular seawater would be all that we would need to generate the power. In addition, it's a clean energy, it's carbon free, and again, there are no radioactive waste products because you're just dealing with varied forms of hydrogen.
So if this is cold fusion, there's no more worry about nuclear waste from nuclear power plants, there's no more worry about climate change and the greenhouse effect. We're sorted.
Yes, I mean, this would be the breakthrough that the world has been waiting for. This would be the source that actually powers all of the stars, able to be run on our very own power stations in our very own homes. We wouldn't have to worry about waste products. We wouldn't have to worry about anything for this generation or the generation to come.
It's amazing stuff. I'll be crossing my fingers. I guess you probably will be too. Thanks so much for your